Okay, we're at 9:01. I think it's probably a good time to get started. Thanks everybody so much for joining us and welcome to the fourth installment of our Green Construction webinar series called How Can Contractors Reduce Embodied Carbon? This webinar is intended to be a follow-up on last month's webinar hosted by Bruce King and Chris Magwood, which gave us some background on what embodied carbon is and why it's important to address. But if you missed it, don't worry about it. It's available on TKN under our sustainability page. And also Václav and Katie are going to give us a bit of a background as well today. This webinar is really intended to expand upon the idea about what we need to focus on as contractors and literally what can we do about it. So presenting today, we have two incredible minds in the sustainability world. Václav Hasík is a data and methodology manager at Building Transparency, the nonprofit organization behind the EC3 tool. Václav was previously a sustainability analyst and lifecycle assessment expert at Urban Fabric, where he managed projects pursuing LEED certification and helped design teams address embodied carbon through whole building lifecycle analyses. Václav also worked as a research at the University of Pittsburgh, where he was involved with university-wide carbon accounting, sustainability planning, and research on data methods for LCAs on buildings. He's an active member of the Carbon Leadership Forum and founder of its San Francisco Bay Area hub. And Katie Paz is our second speaker today, and she's one of our very own. She's a program sustainability lead with a global critical facilities market segment group at Turner Construction. Her passion for sustainability and construction began when she co-founded a monolithic dome construction company in 2012 and was exposed to the concepts of energy efficient and resilient design. She graduated with a BS in Construction Industry Management from Middle Tennessee State University, and during her time at MTSU, she conducted research on the beneficial use of fly ash on low-carbon biocomposite insulation materials. She currently serves on Nashville's Mayor Cooper's Sustainability Advisory Committee, the Metro Nashville Public Works C&D Steering Committee, and is a co-founder of the Carbon Leadership Forum Nashville Hub. So Václav, we could go to the second page. Just before we get started, just a little bit of housekeeping. Please remember to keep yourself on mute throughout the presentation. If you do have any questions, feel free to drop it in the chat. I will be monitoring and giving it over to the presenters later on. And if you're looking for continuing education credits, you can go ahead and log on to usgbc.org and claim this webinar as one of your hours. The instructions for that are found on the screen, and they can also be found on the sustainability webpage for Turner. You can also take a screenshot of this and keep it up on your page if that works for you as well. So I think we're about at critical mass here. I'm going to hand it over to Václav, who's going to get us started on it.
Thank you, Emmy. Thank you for the introduction, and hi everyone. Today I'll talk about the tools and strategies for addressing embodied carbon. I know you've gotten a little bit of a background in embodied carbon in your last webinar, but I'll still recap some of the basics. Then I'll go over into calculating embodied carbon on a project. I'll cover environmental and product declarations and the different tools and workflows that fit into the design process and the procurement process. And then finally, I'll spend a little bit of time on different strategies to reduce embodied carbon, some rules of thumb, but also how you can incorporate different strategies for selecting materials and evaluating designs. A little bit more background on Building Transparency. We are a nonprofit organization focused on sustainability and construction. Our core mission is to provide open access data and tools to anyone in the construction industry to be able to address embodied carbon's role in climate change. Our premier service, as Emmy mentioned, is the Embodied Carbon Construction Calculator, also known as EC3, which is at the core a database of environmental product declarations and the carbon values associated with those documents. So the two features of the tool are finding and comparing materials based on their carbon footprint. And then we also have the plan and compare buildings feature, which allows you to input material quantities and link them with the EPDs that you actually, for products that you purchase on projects. We currently have over 10,000 registered users, and the tool has been continuously developing with the help of over 50 industry partners. Turner is now one of our pilot sponsors, so we really appreciate this support from your organization as well. And with that, let me go into what is embodied carbon, just a quick recap of some of the background. Why does it matter and how is it calculated? You may have seen some of these diagrams on the last webinar, but I'll go over this again. The global CO2 emissions by sector on the left show that buildings account for about 40% of the global CO2 emissions. About 28% are typically attributed to building operations, and then about 11%, sometimes more, are attributed to building materials and construction. So that's also what we call embodied carbon. If we look at the diagram on the right, this is an example of how emissions are attributed to buildings over the lifetime of a building. We start with embodied emissions from the manufacturing of materials, which are, this sharper curve at the beginning of a project over a shorter period of time, but it's typically a larger amount of emissions over a time period. And then we have the operating emissions, which are emitted over the lifetime of a building, let's say over 50, 60 years. What we know today is that, we've actually worked really hard to address operating emissions, and so new buildings are actually able to be near or, near net zero from an operating perspective. However, we still haven't really addressed the embodied emissions, and so you can see that that the emissions by sector pie chart is going to be changing in the future, and especially with new buildings, as we construct new buildings that are energy efficient on the operating side, but not necessarily on the embodied emission side. And so how do we actually calculate embodied carbon and carbon emissions in general? It's typically done through life cycle assessment, which is a calculation approach for environmental impacts of products and services. And it takes into account resource consumption and direct emissions into air, water, and soil throughout multiple stages of the life cycle of products. Embodied carbon specifically takes into account different greenhouse gases such as CO2, methane, N2O, and different HCFCs or hydrofluorocarbons. And each of these gases have different radiative forcing when they're emitted into the atmosphere. And so we come up with a carbon dioxide equivalent value for these types of greenhouse gas emissions. And it's really a measure of global warming potential. So these are some of the terms that you may see in whole building life cycle assessments, as well as on environmental product declarations. In terms of the life cycle stages, here's a complete life cycle stage diagram. It includes product, construction, use, and end of life stages. And each of these have multiple sub-stages. For example, product stage has raw material supply, transport and manufacturing. And then we have construction and installation, maintenance, repair, etc. It's really handy to have this diagram when you are looking at whole building LCA results or even environmental product declarations and understanding which stage the impacts are attributed to. You may see these letters and numbers quite often if you look at embodied carbon. Embodied carbon particularly is at the top of this diagram. It really includes all of the emissions that are associated with the manufacturing, maintenance, and replacement, and also the disposal of products. And then the operational stages are at the bottom. They typically include energy and water use throughout the use phase of the building. And so why else would you calculate embodied carbon besides the fact that it's really important for preserving the climate on our Earth? There are now policy and rating system incentives for addressing embodied carbon. On the federal, we have the federal bioclean program that is now being proposed and developing, which would pretty much require the provision of environmental product declarations on federal projects. We also have bills introduced in 6 states now that do a similar, that approach embodied carbon from a similar perspective, requiring disclosure of embodied carbon values for materials. And California now also published first global warming potential limits for some of the major material categories. We also have local climate action plans where smaller municipalities are enacting their own sort of codes for addressing embodied carbon for different types of materials. And then on the rating system side, if you're working on LEED projects, there are 3 different credits that now address embodied carbon from a whole building perspective through product EPDs and through procuring of low carbon materials. The International Living Future Institute has the materials pedal and the zero carbon certification that address embodied carbon. And then BREEAM has its own credit for life cycle impacts. So that's it on the recap of the background. Now I will switch over to calculating embodied carbon on a project. I will start with the fact that it's really simple on a whole building perspective. All you need to do is collect your quantities of materials and connect them with the impact factors. So for example, the embodied carbon factors for that type of material. As an example here, we have 1 cubic yard of concrete, which can be multiplied by 389 kilograms of CO2 equivalent for the production of 1 cubic yard of concrete. And so if you're an estimator, you are well familiar with this process. What you need is mass, volume, area, or length of different types of materials, and you can get this information from the design or takeoffs. The carbon data is typically obtained from environmental product declarations, which I'll cover in more depth in a few slides. But it can also be obtained from different design-focused tools or different tools that actually collect the information from environmental product declarations. And so these 2 data sources on the right is what I'll cover in the rest of this presentation. I'll start with environmental product declarations, since those may be something that you as a contractor may come across most often, and that you should actually request from manufacturers when possible. Environmental product declarations, also known as EPDs, are an equivalent of a nutritional label for the environmental impacts of products. However, they're not just a single label, as you may see on a box of a cereal. They really are multi-page reports that includes some discussion of the performance characteristics of the different products. It explains the manufacturing process of that product. And it also explains some of the impact calculations that go into calculating some of these impact numbers. These environmental product declarations also have to adhere to what's called product category rules, or PCRs. And they have to be third-party verified, externally third-party verified if they want to be taken seriously in the industry. On the right side, you can see the global warming potential. Again, this is the measure of what we call embodied carbon a lot of the times. There are also other impact categories such as ozone depletion, acidification, eutrophication, and smog formation. Some of these other categories are typically more relevant to something like agricultural products and transportation. Global warming potential really is the most important impact category for most construction products. There can be some exceptions, but generally that's true. So just a quick summary of terms. I know it can be a lot of abbreviations. EPDs, again, environmental product declarations, are basically the results of LCAs for product or group of products. Life cycle assessment itself is an approach for quantifying the environmental impacts of these products. And PCRs, or product category rules, are the rules for conducting product LCAs. And then finally, global warming potential is the impact category that accounts for effects of greenhouse gas emissions. So now that's the basics about how to calculate embodied carbon on a project, and basics of EPDs. Now, what kinds of tools are out there, and how can we implement them into the workflows on an actual project? So if you look at the typical design stages of projects, you have the concept, schematic, design, and construction documentation phases. These are obviously the design focused phases. And so we have different whole building LCA tools which are focused on the design aspects of the building. During these stages, we can evaluate larger differences that the design may make in the embodied carbon footprint of buildings. It can include different shapes and sizes and the location of a building. And you can also compare different types of systems. These design-focused tools typically use an average, single average value for a single type of material. So they don't necessarily let you evaluate the differences between products from different manufacturers. And so that's where the procurement tools come into play. This is where you can now start comparing the impacts of individual products and what manufacturers do to reduce the impacts of their own products. In terms of the tools that are focused in some of these different stages, on the design side, we have the Athena Impact Estimator, Tally, One-Click LCA, and the E-Tool, which are focused on evaluating the larger system differences. One-Click LCA also has a database of environmental product declarations, and so does EC3. EC3 is freely accessible to anyone, and so you can look for product impacts in those two tools. I'll cover briefly the whole building LCA tools, but I'll focus more on the procurement tools later on. Whole building LCA tools typically account for larger range of the life cycle stages. They include the product stage, construction stage, parts of the use stage, and all of the end-of-life stages, so the disposal of products. And they typically, they can be Excel-based tools, or they can be standalone software tools. And we see an increase in actually BIM-integrated tools, where you can go in and associate predefined materials to the elements of your BIM model, and you can quantify the embodied carbon impacts right in the BIM tool. Again, the design stages are more focused on evaluating larger system differences. And so, for example, here I had a couple of different comparisons of structural systems. You could also compare different types of envelope systems and other types of, sort of larger system changes. But now let's focus more on the procurement side, which is more relevant to this group, I think. And I'll give you an example of how you can use the EC3 tool to look for product impact data in our database. These procurement tools focus more on the product stages, really, just how, just at the differences of the manufacturing processes and the efficiency of processes from different manufacturers. These are the stages that are also covered in all EPDs. Some EPDs include some of the other life cycle stages as well, but it's sort of less common. And so let's take a look at EC3 and how you can look for different products that fit your criteria. On the left side, it's sort of small, but we have different material categories. So for example, concrete, masonry, aluminum, steel, wood, etc. And so once you select a product category, what you will see next is these performance specifications that you can select, and you can filter products that fit your performance criteria. In this case, we are looking at an example of cast-in-place concrete products. And so you see in the performance specifications, it's kind of hard to read, but what I highlighted here is the compressive strength, standard weight or lightweight concrete. And then you can also select the geographic region that you want to look for products in. If you're working in a building project, you can also select max distance from the project site, and it will only show you products within that the selected radius. So once we select these performance specifications, we can click on the search button, which is not shown here, but if you go into the tool, you will see it right away. And what we will get is results, the search results of all of the EPDs in the database that fit your criteria, your search criteria. For some of these concrete EPDs, you can actually find hundreds or thousands of mixes that have EPDs in the database. Here, I just selected 6 representative mixes to show you how you can use this tool to compare individual products. You can see sort of the ranges of the embodied carbon impacts, on the right side with the 6 selected materials and how they compare to each other. On the left side, where it says category results, you also see the statistics across the whole. Let's say we have hundreds or thousands of EPDs that fit my search criteria. These category results reflect the whole set of EPDs fitting those performance specifications. And so to zoom in and explain some of the features of this diagram in more depth, we start with the reported value. So for this EPD, the reported value is the black bar in the middle. This is the value that you would see on an environmental product declaration directly. Now, what the environmental product declarations don't show you is that there is actually uncertainty around the confidence in the results. This is just based on the fact that there can be different background data sets used for developing some of these numbers. And so what we do is we apply the EC3 uncertainty range. This is dependent on how specific the environmental product declaration is, how specific the data is to the particular product. And then we come up with the product's conservative value. So we actually recommend that people use this value for comparing across different products that we find. On the left side, we then have the category results again. And these show you the ranges of values across similar products that fit your search criteria. At the top, where sort of the gradient box is cut off, that's the conservative value for your search criteria. And so this basically says that 80% of the products that the tool found falls with it below this number, below this embodied carbon number. In this case, it's 1,431 kilograms of CO2 equivalent per 1 ton of reinforcing bar. And then lastly, the last piece of this diagram is the carbon leadership forum category baseline. And so this is the number that would actually be used in most rating system reporting whenever you're trying to document carbon reductions from a baseline. The difference between the CLF baseline and the conservative value for a search criteria is that the baseline is only done sort of coarsely for the product category. So for example, for reinforcing bar in this case, without any further performance specifications. So for example, if you wanted to select stainless steel reinforcing, that wouldn't necessarily be reflected in the category baseline. That's a static value that is developed for a larger set of products. Also, the conservative value for search criteria is really specific to your search, to the performance specifications that you define in your search. And it changes over time. So if you have more EPDs that are added to this category, that number may actually change over time. And so if we look at the number of EPDs that we currently have available in the tool, we have over 40,000 EPDs for the concrete category. So the concrete industry has really embraced this embodied carbon effort and the supply of environmental product declarations to users. The other product categories are a little bit behind, and we need sort of a larger buy-in into actually making some meaningful action on reducing embodied carbon and making this more competitive for manufacturers to actually try to reduce the embodied carbon of their products. And so that's it in terms of how you can navigate the tool. Now, we are talking about reductions through product choices, especially as a contractor. That's really the leverage that you have. So we recommend that you look for and ask for product-specific EPDs for materials. This really sends a message to manufacturers that we care about the embodied carbon of these products, and it can actually start sort of bringing a competitive advantage across different manufacturers. They start competing for trying to reduce the embodied carbon of their products and actually market it that way. So this is sort of what we need to do. The way that you can address this as a contractor is, this is more on the design side, but you can address embodied carbon in specifications. You as a contractor actually can help sometimes the designer with selecting products that are most likely going to be have lower carbon footprint. So you can focus on actually implementing performance specifications instead of more prescriptive specifications. This is especially important for the concrete category, again, where a lot of the suppliers now know how to reduce the impact of their concrete mixes. But sometimes they get sort of tied up by the the prescriptive specifications. You can also set global warming potential limits or targets within your specifications and really send the message that this is something that the project cares about. On the bidding process side, again, at the minimum, you should be requesting product-specific EPDs, just so, again, you send the message that you care about this, and so we get more data and transparency from manufacturers on the carbon footprint of their processes and their products. You can also use the bid alternate approach for awarding some of the products that have embodied carbon below a target for that project. And then finally, it's at this stage, it's really important to track embodied carbon even after the fact, after you purchase all the materials, to really understand what worked and what didn't, what you may be able to implement in future projects, especially on the availability and costs perspective. For some of the more innovative materials that are out there, there can be availability issues that you may know about, and there also can be some cost implications here and there. For some of the products, manufacturers don't actually charge any cost premiums, but it definitely can happen. So just understanding some of those dynamics is important. And then lastly, this is not as relevant to environmental product declarations and sort of product choices, but temporary construction is typically not covered in whole building LCAs, but we actually know that there are high embodied carbon materials used in temporary construction. So actually calculating and addressing some of those impacts can be significant. Packaging is usually not a big portion of the embodied carbon impacts, but you can also make some reduction dents through looking at the packaging of different materials. And then finally, construction activity tracking. There's currently not a whole lot of data on the carbon emissions of construction activities. And so we as a contractor have a big opportunity in actually tracking that data and understanding your own processes from that perspective. So one of the last slides from the tool perspective is the scope. A lot of people always ask me about, what should I focus on? Do I need to care about nuts and bolts? And the answer is no, you don't need to care as much about the small stuff. The structural and enclosure are probably the minimum that you should focus on. And these are also the requirements for different rating systems. So structure can actually account for up to 80% of the embodied carbon impacts for a new construction project. Enclosure can account for a large portion of the rest of the embodied carbon impacts. Usually the interiors are a smaller portion, but it really depends on the replacement intervals of some of these materials. And there can also be exceptions for some of the interior components. Some of them can have large embodied carbon impacts, which you wouldn't necessarily know until you actually did the analysis. So if you can, it's good to have the interior components as well. But it's typically optional, especially in rating systems. Furniture hardware is typically not covered. MEP systems are not covered, although there is now effort in adding those into the scope. And then site and temporary construction are also typically not covered in the whole building LCAs or product procurement. From a division perspective, focus on divisions 3 to 9. That's generally the rule. Some of the other stages are either hard to address or they don't really account for a large portion of the embodied carbon pie. And so last 2 slides, I think some of the rules of thumb, you may have already heard about these on your previous webinar, but I'll focus on the 3 main material categories. In concrete, 90% of the carbon footprint comes from cement manufacturing. And so focusing on using supplementary cementitious materials is a good way of addressing embodied carbon from a concrete perspective. A lot of the concrete suppliers in the US are starting to be well versed in this area, especially on the West Coast. And so talk to the concrete supplier and ask for low global warming potential concrete, and they will be able to help you out on your projects. On the steel side, it's a little harder to address. But there are 2 major ways of manufacturing steel, and that's through basic oxygen furnace and electric arc furnace. The electric arc furnace route has about 50% lower carbon footprint just by the fact that it uses a larger ratio of recycled content, and it also uses typically lower impact intensity energy for the heating of the metal. In the United States, most of the steel comes from the electric arc furnace. And so if you have a project in the United States or North America, try and source your steel from North America. That's probably the main rule of thumb. Otherwise, ask for product-specific EPDs just so you understand the impacts of the projects that you procure. And then lastly, on the insulation side, avoid high-impact blowing agents, especially in the foam insulation materials, and try and explore if you can use any natural materials as insulation products. Again, I think this was a large focus of the last webinar on using some of the biogenic or bio-based materials for construction, some of it including insulations. And then lastly, reuse components when you can. You can eliminate all of the manufacturing impacts if you can effectively reuse components or even entire parts of buildings. I was working on an adaptive reuse project where a large portion of the structure and envelope was reused, and the project was able to reduce the impacts by 70% versus if they constructed a whole new building from the ground up. And with that, I have a couple of resources here. You can always go on buildingtransparency.org. We have some model specifications and sample bid documents on there for you to use. And Carbon Leadership Forum also has good resources for embodied carbon. So I encourage you to go to some of these websites and look around. And with that, I'll hand it over to Katie.
Thanks, Václav. So I'd like to share with you all a little bit about what Turner has been doing, what our committees are working on, what resources are available, and share some success stories and case studies. Over the last year, 6 committees have been established that are focusing on embodied carbon with the overarching goal of answering these questions. How do we quantify the embodied carbon of our projects, and how can we reduce it? Hunter Howlett and Caroline Murray recently launched a sustainability committee within SourceBlue that is exploring refrigerants and their environmental impact, the embodied carbon associated with manufacturing MEP equipment, and generating EPDs for the materials we are manufacturing at Turner. They are also working to develop marketing materials to show our clients how SourceBlue can help achieve the sustainability goals of our projects. There's also a BIM VDC working group led by Ben Farrer, along with Rohit Sharma and Disha Gattani with TTS, who are developing a workflow for importing Revit models into the EC3 tool. Lucille Baugenwitz is leading the charge on embodied carbon within TEG. Lucille developed a low carbon concrete matrix, generated a list of questions to ask structural engineers alongside Blake Doper, and is a wealth of knowledge on assessing specifications for language that could be prohibitive to reducing embodied carbon. Her group is working to develop a design playbook, which will include best practices for reducing embodied carbon of structural and envelope systems. Their team has already helped several projects to achieve tangible reductions, including assessing the embodied carbon of different structural systems and generating studies such as the one shown here on the left. As you can see, the mass timber structure is by far the better choice when it comes to embodied carbon. This year, we became a pilot partner of the EC3 tool, which our pre-con teams will use to estimate embodied carbon, as Václav explained earlier. Our pilot status gives us access to additional material categories, such as interior finishes, exterior cladding, and more. We also meet with the building transparency team on a bi-weekly basis to share feedback and propose improvements to the tool. We have a robust committee of estimators representing PA&J, Toronto, Texas, Boston, Great Lakes, Philly, Mid-Atlantic, NorCal, SoCal, Ohio, and more. We are learning how to integrate embodied carbon into our existing pre-con processes and developing procedures and resources for our pre-con teams. The first project with a specified embodied requirement just went out to the street to bidders on Monday. Drew Heinzman and Richard Ock in Des Moines have been great partners in making sure our bidders have the information they need to meet these requirements and that the project is set up for success. Right now, the pre-con committee is building templates in the EC3 tool for various project types. And we recently completed an analysis on a higher education project with quantities from our latest estimate. Next, we will be creating a template for a carbon value engineering matrix. The pre-con committee has grown rapidly, and I am excited to see what this group will accomplish next under the leadership of Rowan Paris, an estimator and sustainability manager in Charlotte. The procurement committee, led by Christina Alvarado in SoCal, is developing a toolkit for procurement agents that includes training materials for subcontractor and supplier outreach, sample contract language, and environmental product declaration resources for bidders. We've met with ready-mix suppliers in Pennsylvania, Nashville, Chicago, Des Moines, San Antonio, Columbus, Omaha, Virginia, and Wyoming to educate on the topic of embodied carbon and on how to procure EPDs. We also discussed low carbon concrete technologies, including local market availability, cost, quality, and constructability. The owner's first question is always, what is this going to cost me? So we're working on answering that question too. Not all of our trade partners and material manufacturers understand embodied carbon yet, and we are prepared to educate our trade partners and material suppliers so that we can effectively collaborate to meet the embodied carbon goals of our projects. To track and document these ready-mix supplier conversations, we are working on an interactive map which indicates which suppliers we've met with, if they have mix-specific EPDs, what low-carbon concrete technologies are available locally, and frankly, what they are comfortable with using or what they have experience with. And these conversations have been very enlightening. We are working to make this map accessible on TKN, so stay tuned for that. The Concrete Committee was the first subcommittee established, and for good reason. With production of cement alone contributing 8% of global emissions, we knew we needed to start there. To put that statistic in perspective, if concrete were a country, it would be the world's third largest greenhouse gas emitter after China and the US. We've conducted extensive research and market outreach over the last year with companies such as CarbonCure that injects carbon dioxide captured from industrial processes into a concrete mix at the batch plant. This reduces the amount of Portland cement needed by about 3 to 7%, doesn't have any negative impacts on pumpability, workability, and actually has a positive correlation with increasing compressive strength. Biomason is growing biocement with natural microorganisms and producing bricks and pavers. You heard me right, they are growing bricks and pavers in a lab. A company called Positive just opened a facility in Connecticut, and they are taking post-consumer recycled glass, putting it through an acid washing process, crushing it into a fine powder, and able to replace up to 50% of the Portland cement content in a mix with a product called ground glass pozzolan. Not only is this having an impact on the carbon emissions of the concrete, but it's solving a glass recycling problem that many jurisdictions are trying to solve. We've also met with Nucor and the American Institute of Steel Construction to learn about reducing embodied carbon in steel. Looking forward, a company called Blue Planet is harvesting carbon dioxide from industrial processes and manufacturing a synthetic aggregate, locking that carbon away. Use of this aggregate in a mix results in an average 220% improvement in carbon emissions. That's right, using Blue Planet results in a net carbon positive mix, meaning more carbon is stored than emitted. Be on the lookout for that material to appear on the market in the next 5 years. So we've recently rebranded ourselves as the Materials Committee, as we want to expand our knowledge base to other systems and materials such as aluminum, exterior facade, and carbon sequestering materials, such as the one shown on the right side of this graph, and which you heard a little bit about at our last webinar with Bruce King and Chris Magwood. Things like hempcrete, bamboo, straw, clay, and earthen materials. I realize the impression may be we could never use these on a Turner job. Maybe I could build a straw bale hut in my backyard. But there are groups working within ASTM to establish standards on these materials and groups working to incorporate them into building code. I noticed a couple of questions in the last webinar about fire ratings and longevity of some of these materials. I want to assure you that as we talk about reducing carbon in our projects, that doesn't mean we are sacrificing quality. And these materials will go through the same rigorous testing and standardization that all of the materials we use have gone through. With the existing and emerging technologies, we have the capability to make our buildings carbon sinks. By utilizing the materials on the right side of the chart, we can really make a significant impact. I want to point out our Embodied Carbon Resources page on TKN. There are videos, links to external websites, the low carbon concrete matrix, and a launch matrix there. And we are constantly adding new content, so I encourage you to check it out. I'd also encourage you to get looped in with your local Carbon Leadership Forum hub to stay up to date on local educational and networking opportunities. So next, I'd like to share a few case studies of projects where we have actually achieved results. The SPO Concrete team in Seattle, led by Dave Maynard, conducted this study on the Seattle Aquarium. The baseline global warming potential values are the National Ready Mix Concrete Association industry averages for that particular PSI. And the actual global warming potential is the value taken from the mix-specific EPD that the subcontractor proposed for each of these applications. The project was targeting a 30% reduction, but exceeded that and achieved a 43% reduction on this scope. The owner agreed to pay a small premium of $55,000 or about $8 a cubic yard. And just a disclaimer there, cost premiums for low carbon concrete will vary greatly by region and by what technologies are utilized. The Brandon Square project was able to reduce emissions associated with the grout used in the pile foundation system through collaboration between the Turner team, including operations, sustainability, TEG, and the Deep Foundation trade partner. The trade partner proposed alternate mix designs that met the engineering, structural, and performance criteria. TEG reviewed and validated the mixes, and the result was a 19% savings in emissions compared to the baseline specified mix, which already utilized fly ash. This savings was achieved at no cost premium. On a data center project that is currently in pre-con, we utilized EC3's Find and Compare Materials feature to compare the two products that are specified for a below-grade board insulation. On the far left, the box plot and whisker chart shows where the highest concentration of GWP values fall within that dark green box here. The two specified products are shown in the middle. As you can see, the global warming potential values for the specified products are much higher than the majority of the products in the EC3 database. By entering the performance requirements from the specification, we were able to identify a third material that appears to meet the spec requirements that our trade partner is going to evaluate and price as an alternate. These options will be incorporated into our carbon value engineering matrix so that the owner and design team can assess the options from a carbon and cost point of view. Morel Hartman, an estimator in the PA&J region, recently completed an EC3 analysis on the Penn State LARTB project, which is currently in design development. The baseline analysis for this job came out to roughly 8.5 million kilograms of carbon dioxide equivalent overall for the project. The Sankey diagram tells us where the greatest opportunities are to reduce embodied carbon. As you can see here, we should focus on the concrete and steel on the foundation superstructure. As Vaclav mentioned earlier, most of the carbon is underground. The project had to add a micro-pile deep foundation system, and the addition of the steel for the piles alone added roughly 1 million kilograms of carbon, or about 1/8 of the overall project footprint. Through this analysis, we've advised the project team to explore opportunities to utilize recycled steel for the piles. We also used the EC3 tool's embodied versus operating feature. By plugging in the operational energy use intensity and percentage of natural gas and electricity, a chart is generated that compares the embodied versus operational emissions over a 30-year time span, which is a great visual to share with the design team and client. So what can we at Turner do now on our projects? We've developed an Embodied Carbon Services one-pager, which outlines how we at Turner can help our projects realize a tangible carbon savings from concept development through to completion, and this can be found on TKN. If you have a client that is interested in the topic of embodied carbon, you can incorporate this into your proposal or send it directly to them. I won't go through all of these in detail, but if we have a seat at the table during concept development, the biggest impact by far is for the client to reuse an existing building and to not build a new one. As Bruce mentioned on the last webinar, if a building has good bones, why tear it down? This decision alone will have the biggest impact on emissions. If that just isn't an option, evaluating the type of structure, such as concrete, steel, or mass timber, should be the next step. As I mentioned before, TEG can get involved to review the design and provide recommendations. Recently, TEG also conducted a third-party peer review of a whole building life cycle assessment for a project in SoCal. As we begin pre-con, we can build a carbon estimate, propose lower carbon alternates, and educate our suppliers and trade partners. During construction, we can track emissions associated with material deliveries and the construction process itself through our metering program. We can help the project to achieve third-party certifications, such as pursuing USGBC's new procurement of low carbon construction materials pilot credit, which can earn a project up to 2 additional points. At the end of the project, we can generate a report that details the project's design, material procurement, and construction stages embodied carbon emissions reduction. I want to end by saying the amount of collaboration and learning on this topic that has happened over the last year has been simply amazing to be a part of. As hard as this last year has been, I believe that the increased virtual format has actually increased collaboration across our company, as I've shared with you today. Thank you to every single person who is volunteering on a committee, taking time out of your busy schedules to get smarter on this topic, and for being here today. I realize that we can't visibly see the results of reducing embodied carbon. We can't see the greenhouse gases in our atmosphere. But based on current climate science and predictions, this is some of the most important work we can be doing as a construction company to reduce our environmental impact. And I want to assure you that the work you are doing is making a difference. It's making a difference for profits and helping us to win work and strengthen our relationships with our clients and our design partners. It's helping our people and preserving our planet for future generations. The triple bottom line. If you're interested in learning more about how you can reduce the embodied carbon of your project, feel free to reach out directly to myself or Emmy, and we'd be happy to help you get started. With that, I'll hand it back over to you, Emmy.
Great. Well, thank you Much for that phenomenal presentation. Really appreciate it, Vasav and Katie. We do have a number of really great comments coming through in the chat. So I'm going to start with one. If we request the EPD from subcontractors, should we expect this request to cost additional money, or are the EPDs something that are readily available to the subcontractor/supplier? So I'm going to give this to you, Katie, because you're kind of living this day to day out in the data center world.
If they are not available, there are third parties. There are several companies that can generate EPDs. There is a cost associated with it, and it's a very time-consuming process. It can take, currently, what we're hearing is anywhere from 6 months to up to a year. So we can certainly steer them in the right direction to procuring and obtaining those EPDs. And that's kind of part of our Ready Mix campaign, is to give our suppliers a heads up. Hey, this is coming. We have more clients asking for this. We're strongly encouraging you to start the process of getting EPDs.
I would also add to that that the cost and the time intensity really depends on the type of material. So there are different tools now being developed to actually streamline the development of EPDs. So for example, on the concrete side, we have seen significant reduction in costs and time commitment from manufacturers to generate EPDs. But for some of the other products, it can take, quite a bit of time.
We also have another question about EPDs, speaking about the verification and accountability process for EPD accuracy. So specifically, they cited concerns about, how VW was responsible for self-reporting some numbers, and it came back with some fictitious data. So how can we as contractors trust the information presented in EPDs as being reported accurately and fairly?
Yeah, that's a great question. And I'm going to say right off the bat that the verification process is not perfect by any means. Right now, the third-party verifiers, so let me start this way. Most EPDs today are third-party verified, so at least someone not from within the company is taking a look at the data, and that's being reported. But it's there are only a handful of EPDs that are internally verified, that wouldn't go through that process. And typically, people don't give a whole lot of weight to the internally documented and verified EPDs, just because of the reason that you just mentioned. It's sort of self-reported. It's hard to actually know if everything was done correctly and really transparently. So the third-party verifiers have at least you have outside third-party verifiers that look at these EPDs. However, it's sort of hard sometimes to actually assess the full correctness of an LCA model. There are, ways that that the third-party verifiers can do it. They typically look at the major reported numbers for energy, inputs into the manufacturing processes, and what sort of background data has been used in the EPDs. So you can tell, so you can verify the quality of the EPD from that perspective, but we still see some inconsistency sometimes. So what you can do, especially in EC3, is actually look at the side-by-side comparison of products. And if you see that the numbers are widely different, you can then either ask the manufacturer, for more information, or you can reach out to our team, since we spend quite a bit of time on actually looking through these EPDs and do a bit more digging for you. But hopefully in the future, we can improve this verification process itself, make it easier for verifiers to actually to analyze the underlying LCA models.
Great, thank you. We also have a question from Emily. She asks if there's any, and Emily, come off mute if you think I misquote your question here, but any cases of owners that have created long-term maintenance and disposal plans for their buildings to make sure that we're minimizing the impact of building disposal. Did I get that right, Emily? don't know if Emily's still on, but does that question make sense to you, Katie or Vaslav? Have you ever heard of owners creating long-term maintenance or disposal plans for their buildings to minimize life cycle impact?
This actually came up recently. We were presenting to a client, and they had a question about the correlation between lower carbon materials and the longevity and long-term maintenance of those materials. And I think in their mind, they thought that some of these lower carbon alternates might not last as long. So there are definitely clients that are thinking, especially on the higher ed side of things, this building, we want it to be here and be in good shape for 50, 60 years. So that's definitely part of their thought process as it relates to the materials they're selecting. So yes.
We have a question from David Arnold. Is there a simple cheat sheet that can be shared to give people who are not versed in GWP values and EPD components that could give a guide for ranges and values to shoot for? I don't know, Vaslav, if you can speak to EC3's capacity on that.
Yeah, I would actually say that the CLF, the Carbon Leadership Forum baseline document might be the best one. So you don't have to go into the tool and actually look for the data yourself, although I would recommend that route because you get the actual data from environmental product declarations. But yeah, I would refer to the Carbon Leadership Forum baselines that they have. I think it's like a 10-page report, and it has some of the major material categories and the ranges of global warming potential values that you can expect for those categories. So that would be a good start. Great,
and I wonder if you might be willing to drop that in the chat for us, Vaslav. I'll finish it out with one last question, and this is just a larger general question for both of you. Katie, maybe you wouldn't mind starting, but if a person on this call were to get a request from a client to start looking into embodied carbon or reducing embodied carbon, where would you send them first? What would you say the first steps are for them to get started on the process?
As far as what we can provide, definitely that embodied carbon services one pager, which is on TKN. There's also a really great report that Emmy wrote for a client just on the state of the market and deeper dive into strategies for reducing embodied carbon with certain materials. And then we also have our metering sheet for clients. So those three would be a really great starting point just to showcase what we can do. And then honestly, just schedule a embodied carbon charrette. Let's get the design team, let's get the owner, us, and especially the ready mix suppliers and our trade partners involved and start talking about this as early as possible. That'd definitely be the best place to start.
Great. And Vaslav, do you have any final thoughts on how people can get started on embodied carbon?
I think if you're completely new to this topic, I think the materials palette, I'll drop the link as well, is a good start of just understanding how the different materials are manufactured and what sort of embodied carbon impacts each material type has. It's a nice visual overview of those differences between materials. But then really just quantifying the embodied carbon on projects and learning through the process of doing these analyses is I think the best long-term approach in understanding embodied carbon.